Hey crew, welcome back to another installment of Mr. Hawkins' awesome geometry class. Today we're going to continue on with our Unit 9, which is dealing with two-dimensional measurement called area. We're going to kind of review all the types of area problems that we've done so far, and then I'm going to add a new type to it. Alright, objective for the day is to be able to find and use similar areas. And I'll show you what I mean by that. But first, a review of everything that we've done so far. Again, I started this unit with parallelograms. That was simply base times height, where base and height had to be perpendicular. Again, over on this parallelogram, I see the perpendicular right there, meaning that this must be the height and this must be the base. So this would simply be 12 times 5. And that's equal to 60 square units. Over here, now I have a triangle. Remember, that's just half of a parallelogram, so that's half the base times the height. Base and height still need to be perpendicular, so this is my perpendicular right there. So this must be the base and the height, so this one would be simply 1/2 12 times 6, which is equal to 36 square units. Then we moved on to trapezoids. Remember, that's 1/2 the height times base 1 plus base 2. Base and height still need to be perpendicular, so that means 7 is my height, and these are the two bases. So filling that in, it would be 1/2 of the height times the two bases added together. So that one, I might have to go to the calculator on that one. 6 plus 12 is 18. Half of 18 is 9, so no, that's 63. Kites and rhombi had the same formula. They used the diagonals, so that was 1/2 d1 times d2. Diagonals are the d's, so it would be 1/2 of this diagonal, which is 11, times this diagonal, which is 6. So that's going to equal 33 square units. Then we had circles and sectors. Circles was just pi r squared. A sector was like a slice of pizza. It was like a fraction of the circle. So you took that central angle, put it over 360, then multiply that times pi r squared. And that x is the angle coming from the center angle. So over here I see I have a diameter of 28.6. I need to get a radius on this, so I'll have to divide that by 2. So 28.6 divided by 2 is what, 14.3? So I'm going to use that as my radius. They want me to find the area of this whole circle, so I'm going to use pi r squared. So pi 14.3 squared. Again, I'd probably use the pi button on my calculator for that one. So that would be pi times 14.3, and the squared button's right here. And so if I round that to the 10th, that would be 642.4. 642.4. So that's a circle. Then we moved on to regular polygons. Regardless of the number of sides, they all had the same formula. Formula for regular polygon is 1/2 AP, where A is the apothem and P is the perimeter. So down here, I'm given a triangle. Again, I'll always give you one of the sides. So I'll give you that. I forgot to write that side down. But the apothem here is 4. So in this one, I would do 1/2 the apothem times the perimeter. Well, there's 3 sides that are 6, so I just simply multiply 6 times 3 to get the perimeter. So that's what? 18. Half of that is 9 times 4 is 36. Then the last thing we looked at was composite figures, basically cut into pieces and add them up. Cut into pieces and add. So over here I kind of see 2 pieces right here in this half a circle and then this rectangle. So again, the rectangle, that's going to be base times height, which in this case is going to be 8 times 10, and that's equal to 80. Then I'd add that to this circle, which is going to be half a circle. So that's going to be pi r squared divided by 2, because it is a half a circle. So in this one, it's going to be pi. The diameter is going to be the same as this, is 8. So I need the radius, which would be half of that, which is 4. So this would be pi 4 squared over 2. So let's see, half of the 16 is 8, so this is 8 pi. So now I need to add this to this. And I'll have my answer. So again, I go to the calculator on that one. 80 plus 8 pi. And that's 105.1. This is 105.1. square units. So that's everything we've done so far. So today we're going to add to that. We're going to go take a look back at something that we did in Unit 7, which was similar polygons. Remember, similar polygons, these are the same shape, different size. Same shape, different size. Remember that the angles were congruent. Corresponding angles congruent. Corresponding sides were proportional. Proportional means equal ratio. Equal ratios. So when you make ratios, they all reduce down to the same thing, is what proportional means. So I have examples of similar polygons here. It wants me to find the ratio of their sides and the ratio of their areas. The ratio of the sides, I'd match up corresponding. So corresponding side here, 4, corresponds with this 2. So again, if I put that into a ratio and reduce, that goes down to 2 to 1. So if I match up the 8 and the 4, again, that's also going to reduce down to 2 to 1. So that is the ratio of the sides, 2 to 1. The ratio of the areas, well, I got to calculate the area. 8 times 4 is what, 32? 2 times 4 is 8, so that's the area of those two. So if I put those into a ratio, 32 over 8, well, I can reduce that. 8 goes into 32 4 times, so that's 4 to 1. So the areas are 4 to 1. Looking at these rectangles. So again, matching up corresponding sides, 6 and 8 correspond. They go down to 3 to 4. 9 and 12, that also goes down 3 to 4. Then if I take the areas now, so this is going to be 9 times 6 or 54 for the area. This is going to be 8 times 12, which is 96. So this would be 54 to 96. So I need to figure out what that reduces down to. I'm going to have to go to the calculator on that one. So again, I would do 54 over 96, do math, enter, and that goes down to 9 to 16. So in this one, the sides were 3 to 4 when I matched up corresponding sides. The areas were 54 to 96, reduced down to 9 to 16. And lastly here, I'll do this one in pink. Again, the sides, I'd match up 4 and 6 because they're corresponding. That's 2 to 3. 10 to 15. That also goes down to 2 to 3. So the ratio of the sides here is 2 to 3. Areas would be 4 times 10, which is 40. This would be 6 times 5, which is what, 90? So now, if I may find the ratio of the areas, 40 to 90 goes down to what, 4 to 9? All right, so now I want you to notice a pattern here. There's a definite pattern forming. Notice that the sides were 2 to 1, the areas were 4 to 1. Notice that the sides were 3 to 4, that the ratio of the areas is now 9 to 16. So how can I go from one to the other? Again, down here, it goes from 2 to 3 to 4 to 9. Well, basically, all I had to do was just square this ratio to get this one. So 2 squared is 4, 3 squared is 9. 3 squared is 9, 4 squared is 16. 2 squared is 4, 1 squared is 1. So basically, if you know the ratio of the sides is like, for example, A to B. That means the ratio of the areas, all you have to do is just square it, and you'll get the ratio of the areas. So that's what we're going to look at today, is similar areas. Again, if you have the side ratio, just square it to get the area ratio. So let's see. Example problems. All right, so finding areas. What you want to do is you want to find the side ratio. Square it. And then use a proportion. So I'll show you how to do these. So in this one here, I want to find this missing area. I know for a fact they're similar. I have a pair of corresponding sides in the 12 and the 15. So again, the first thing I want to do is find the side ratio. Well, that's pretty easy. The side ratio would be 12 to 15. Take a 3 out of both, that's 4 to 5. So the side ratio is 4 to 5. So this is the side ratio. Remember, the area ratio is just going to be that squared. So the area ratio is going to be 16 to 25. Again, 4 squared is 16, 5 squared is 25. So now I can use this in a proportion. So side ratio is 4 to 5. Area ratio is 16 to 25. So I'm going to use the 16 to 25. Alright, so I know one of the areas is 30. Notice it's on the smaller triangle. So the area of the smaller one, I can use it to find the area of the big one because I know what the ratio should be. So now I'm going to put that 30 on top with the smaller, and I'm looking for the larger area down here. So now I cross multiply, I get 16x is equal to 30 times 25, 750. And then I divide the 16 into 750, and I end up with about 46.9. And that ends up being the area of the larger. Alright, so let's try another one. Down here, I have these rectangles now. So again, the first thing I can get is the area of the sides, or the ratio of the sides. Again, 8 and 5 does not reduce. And then all I got to do is just square that. 64 to 25. And that's what I'm going to use in the proportion. So the side ratio is 8 to 5. Area ratio is 64 to 25. Set up my proportion, 64 to 25. And now I know the larger one, so I have to make sure I put it with the 64. And I'm looking for the smaller. Cross multiply. 64x is going to equal 25 times 32. And that's 800. And then I got to divide 64 into that. So divide 64 into that. That's 12 and a half. So 12.5 is the area of the smaller one. All right, so that's one kind. Completed notes are in the file. The other one's where you're going to be asked to find a side. In this one, you're going to be given the areas. So in this one, you're going to find ratio of the areas. And then you're going to square root it. And then use a proportion. So watch how I do that. So here, again, I'm given the areas instead of the sides, which means I can make the area ratio, and then I got to reduce that. So the area ratio is going to be 54 over 150. So remember, you got to reduce that on your calculator. 54 over 150. Math, enter, enter. And that goes down to 9 to 25. 9 to 25. And remember, that's your area ratio. 9 to 25. So I just did that, found the ratio of the areas. So now I need to square root that ratio to get the ratio of the sides. Well, square root of 9 is 3. Square root of 25 is 5. So now I'm going to use that in a proportion. So 3 to 5. I'm looking for the smaller one, so that goes on top. The bigger one goes on the bottom. 10. Cross multiply. 5x is equal to 30. Divide by 5. That means x is equal to 6. So another example would be these trapezoids down here. Again, I can get the ratio of the areas. 50 over 72. 50 over 72. Math, enter, enter. And that is 25 to 36. So the area ratio, 25 to 36. Square root it to get the side ratio, 5 to 6. That's what I'm using in the proportion, 5 to 6. I know the smaller one is x, so that goes on top. The larger one is 6, that goes on the bottom. So then cross multiply, 6x is equal to 30. That means x is equal to 5. So that's the way you do these, is basically you're making ratios. Remember that if you have the ratio of the sides, you have to square it to find the area ratio. If you have the ratio of the areas like we did on these, we had to square root to get the side ratio. So if problems for homework for you to try on that, remember as usual, if you have any questions, email me or stop in my office hours and we can discuss that. I look forward to working with you in the future. See you now.